Okay, we've got the carrots, the onions, the celery, the garlic, the chicken, one bouillon cube dissolved in hot water, and 2 containers of this College Inn chicken broth. Now we need to bring this up to a boil and cook it for a while. You never knew this was going to turn into a cooking show, huh? Okay, as the electric range cycles off and on, you can see the current change. Now there's a 16.2 amp, 17 amp load coming out of the HumSync batteries, but the charger is still running. So once the electric cooktop cycles off, now you can see current flow back into the batteries positive. There's 6.2 amps flowing back into the HumSync batteries. And this is the whole design of the system. I'm cooking on top of the electric cooktop stove. It's a 240 volt stove. But the house is being run by a small 3200 watt inverter generator that's slowly charging the battery bank, and the battery bank and the large low frequency inverter is actually powering the house. So that's the whole point of this setup here, a smaller generator that's more easily portable and can be replaced less expensive than what a large whole home backup generator would be. And so I think this is really the best of both worlds, having a battery bank that can power your house for extended periods of time, as well as having a generator to increase the runtime or recharge those batteries in a power outage condition. So I know a lot of people have done this before. I know a lot of people buy commercially made products to do this, and a lot of people have built their own systems. This is just my version of it, and I really think that this is about as inexpensive as you could possibly do a setup like this, based on entry-level type 12-volt batteries configured into a 48-volt battery bank. Well, it's not ideal, and a 48-volt battery would be better to maintain balance as a backup system. This works great as long as you're paying attention to it and doing some regular maintenance, where you may have to rebalance your battery bank every few months or every 6 months or so. Depending on the amount of use it gets. I don't see any issues with this, and like I said, this was originally put together as a hobby for me to tinker with as I get closer to retirement, as I'm quickly becoming an old man, and so I actually really am enjoying this and starting to also put together these little YouTube videos. So I appreciate everybody who is following along and your patience as I try to get better with making these little clips. Okay, I'm going to have to add the pastina now into the soup and get this finished cooked up here. Figure while you're testing and while your wife's sick, you might as well be useful and make her something, hopefully make her feel better. Okay, the generator's still running. We've put in 2.58 kilowatt hours back into the batteries in almost 2.5 hours. We're still running on that original gallon of gas, and everything's still looking good. Running just like how I'd planned on the system to work, other than I'm just using, like I said, one charger right now. That one charger is maintaining in that 2.5 hours time. The batteries were basically at 84%. 2.5 hours ago when we started the generator and turned on this one charger. Like I said, we've been now cooking dinner. The furnace has been running. We've had lights on as needed. It is daytime, so we don't have a lot of lights on. But the furnace has been cycling off and on as normal, and the cooktop stove is on, and the battery bank is staying right at that 84% level. For the last 2.5 hours, it stayed right there. So the calculated estimate of what the house uses per hour is about 800 watt hours per hour. So we're around that 800 to 1,000 watt hours per hour. And so basically a kilowatt of energy every hour. And that's what the generator's been putting back in, about 1 kilowatt every hour. And the house has been using about 1 kilowatt every hour. So like I said, the battery in 2.5 hours has stayed right at that 84% charge level. So everything's working good so far. And dinner's going to be done in a little while. Okay, the soup is finishing up. The pasta is just about all finished cooking in there. It's looking really good. I'm quite excited about this. This is like the adult version of the Campbell's soup that had the chicken and stars. Back when you were a little kid, you used to eat that soup. So this has to cook a little bit longer. I'm going to go out and check the fuel, see if I can see how much fuel is left in the generator. Like I said, it's been running about 2.5 hours. And by the time I come back in, this probably will be ready. And I've had the request to serve dinner in bed today. She's not feeling well. Well, it's been running a little over 2.5 hours now. I took a picture inside the gas tank. I didn't want to put my iPad right up that close to the generator, and I'm sure the audio would be terrible because I heard what my other video sounded like earlier in this series. And so I took a picture, and I'll insert that into the middle of this. It's hard to tell how much fuel's in there, but I would say it looks like it's slightly below a half tank still. So it's hard to guess how big that tank is as far as like where the level is in there. But it looks like it's about halfway down. There might be a third of a tank left, but it's somewhere between a third of a gallon and half a gallon left right now, which surprises me. So we'll see how much longer it runs. Like I said, it has been slightly over 2.5 hours.